Haha! U31, which is our column driver. Select. Pin 11. Goes to 11. On U, what was that? U31. Which is our column, or row driver, sorry. I'll keep screwing this up until I'm all done. So I know where columns 12, 11, 10, 9, row, and the tape driver come off. Now, pin 1 on 31 is used for something. He comes off of U18. So the clock inputs are understood. The enable on this guy is not yet. This guy is on the same bus as this guy down here, just a different pin. And the data bus is laid out flat across all these chips, so they don't have the address bus twisting between pins between all these chips. So I can just go 470 ohms to ground, plus 5 volts, 330 ohms. Because that is the same between both. Okay, let's leave it like that for right now. What else do I got in here? Okay, so I was down to U39. So where does U38 go? Okay, he pops through to right there. He goes to right there. Ooh, then goes down to 1, 2, right there. Goes to that 138 right there. U38 goes to U11. So I'm gonna put another 138 in here. And then I need to make a bunch of boxes. This is U38, which is number 8. Pin 11. Okay, 37, I bet it's pin 9. 36. 35. 34. 33. 32. Skip 30. Yeah, skip 31. 30. That's 15, 30. Yep. So, U37, U36, U35, U34, U33, U32, U30. Oops, 6, 5, 4, 3, 2, 1. So the address map coming off these 138s is relatively flat. So 1 through 7, or 1 through 8 on the first one, you know, for decode 00 through 7. And then 9 through 12 and the road driver are on the second 138 on 0 through 5. 6 and 7 aren't used, and 5 was the tape drive, which isn't there anymore. So I bet you these two are tied together on their address pins. So let's check that. Which are pin 1, pin 2, pin 3, right? 1, 2, 3, 4, 5, and 6 are the address decode. But first, so we got A, B, C, A, B, C, which is 1, 2, and 3, 1, 2, and 3. And they are just bussed together. Pin 7 on this guy did go somewhere. So I got a dot right there. Yeah, it's right there. So he was used for something. What was he used for? I totally don't need to know this information, but my OCD will get the best of me. He goes to right there. Pops out right there, and goes right there. I went to U15. U15 was the status LEDs, I think. Or was that the pen input one? That's the pen input. That still leaves me with this corner one, which is a little odd that they'd skip an address like that. Whatever. Yes, it's going to bother me, but so what? Figure it out later. Okay, next up, there's the 3 base address pins, these 3 to 8 decoders. So that's these 3. So for all binary combinations on these 3 input pins, one of these outputs will go low. Now on top of that, there is 3 gate inputs. And what the gate inputs do is when any of these gate inputs are active, it prevents this from decoding. So it lets you expand the address map of these chips. And they're 4, 5, and 6. And I bet we'll find some tied to ground, some pulled up, and some hooked between the 2 chips. So let's start with U23. 1, 2, 3, 4, 5, and 6. Nobody's pulled up. 6. 5 is grounded. So 5 is grounded on U23. Yeah, so here shows a picture of that gate input. So basically gate 1 is inverted. All the rest are all ANDed together and feed the inhibits to the output gates. So when these 2 inputs, either one is high or this input is low, the outputs will all be high. So pin 4 and pin 6. 1, 2, 3, 4 and here. I bet goes to pin 6 over here. 4, 5, 6. Nope, got that wrong. Nope. Okay, 4 over here. Oh, interesting. Pin 4 goes to pin 4. Four, 5. 4, 5. 6. 6 is pulled high on this guy. Four, 5, and 6. Just double check he's not pulled high. Nope, he's not. So that just leaves me pin 6 on this one to figure out where he goes. Don't see anything on the top. 3, 4, 5, 6. But I do see it on the bottom. So there's a trace off of pin 6. Comes around, 1 in, 3. See, that's address line 4. That was a memory chip that I was just poking on, so let me bring up the data sheet for that and find out what address pins that was. Oh, which way was pin 1? Pin 1 was right there, so... Okay, so 1, 2, 3, 4 are 3. 1, 2, 3, 4. Pin 5 is address 0. One, 2, 3, 4, 5. So this is address 0 right here. And okay. Next one up is address 2. Next one up is address 3, and then it comes back to address 4. Zero, 1, 2, and 3. There you go. Zero, 1, 2, 3. I'm wondering if bit 5 on this other one should also go to address 3, but it doesn't. So let's find out where he goes. 3, 4, 5. 3, 4, 5. Yeah, nothing to see on that side. Now, one thing that could be going on here is when I pulled the memory modules out, I might have damaged a pad, and that's why these two aren't connected anymore. If I have to, I can just bridge the connection with some wire. Which, if I cut this down to a smaller size, I'm going to have to bridge a lot of them. There's going to be a lot of connections I have to go fix anyways. Yeah, because I'll be cutting right along this row here. So, cutting these down may not be the best idea in the world, but we'll see. Okay, so 1, 2, 3, 4, 5. Goes there. Pin 1, 2, 3, 4, 5. Yep, goes right there. So let's just track it through. Yep. So 6 hooks to 5. So the 6